Hello everyone, and welcome back to another remote sensing lecture video. And in this video I want to sort of draw ourselves back a little bit while still talking about electromagnetic radiation. And so if you remember in our previous videos, we laid out this idea of electromagnetic radiation as a wave. And we defined one key term as the distance here from one peak to another peak as wavelength. Right? Hopefully that's a review for you. We talked about this in the previous video. So what I want to do today is I want to take a step back, and I want to think about not just one wavelength, right? So we can define this distance as wavelength. Not just one wavelength of radiation, but many, in fact, all of the wavelengths of electromagnetic radiation. Because if you step outside and you look around, right, you'll see all these different colors. And we haven't really talked about this connection yet, but wavelength is sort of connected to this idea of color with human perception. Right? And if you walk outside, you'll see all these different colors. So clearly, electromagnetic radiation doesn't exist at just one wavelength. Right? It exists at a multitude, right? At almost infinitely many wavelengths. And so what I want to do here is I want to sort of formalize this idea of electromagnetic radiation existing at nearly infinite wavelengths by talking about this idea of the electromagnetic spectrum. Talking about this idea of the electromagnetic spectrum. And so I think because we're talking about the electromagnetic spectrum, and we're talking about it from the perspective of a spectrum, that it might actually be useful to just lay this thing out on a spectrum. So let's go ahead and start off with a nice straight line. Right? So what I want to do is on one end of this, maybe down here, I want to have this be our short wavelengths, right? Short wavelengths. And over here be our long wavelengths. Right, so again, this is a spectrum from really short wavelengths to really long wavelengths. And I like to sort of start this discussion by giving some context of some things that you may not necessarily think about when you think about things like electromagnetic radiation and wavelength, but that really do actually belong on this spectrum. And on the short end, right down here, we have something called gamma rays. G-A-M-M-A rays. Right? So this is if you're familiar with the idea of the Hulk from the Marvel Universe, right? When the Hulk was bombarded with gamma radiation that turned him into the Hulk, that's what we're talking about, right? So on the short end of the electromagnetic spectrum, we have the gamma rays. And then we go longer and longer and longer. As we get out here, we start to get into things like radio waves. Right, so when you're driving your car and you're listening to the radio, right, that wave that's passing that information back and forth, those are called radio waves, and those also belong on the electromagnetic spectrum. So again, these are just two examples. Some more examples in the shorter end, we have things like X-rays. So when you go to the doctor, when you have a broken bone and you get an X-ray taken, they're bombarding you with X-rays. An example of something with a slightly longer wavelength would be something like microwaves. Right? When you sit at home and you want a bag of popcorn, you put your little bag in the microwave, right? That microwave is emitting microwave wavelength electromagnetic radiation to heat the food up. So again, I don't necessarily expect you to memorize all these different regions, but just to give it some context and sort of tie this into things that hopefully are more commonplace for you. What I really want to focus on, because we're talking about optical remote sensing, is this very special region that occurs, and this is not to scale, so please don't think that it is. There's a very special region. It's so special, even let's do it in a different color. There's a very special region that occurs, I'm going to make it small here, from about 400 nanometers to about 700 nanometers. Right? And this region is called the visible region, or the visible spectrum. Visible spectrum. And the best way I can describe this is if you think about a rainbow, right? When you walk outside after it's rained and you look up in the sky and you see a rainbow, right? That's the visible spectrum, right? That's all the wavelengths of light that we as humans can see. So let's specify that out. This is all wavelengths humans can see. Now, I should say I use humans here because that's how we've defined it, but it turns out from a biological standpoint and a biological perspective that a lot of really important processes in the animal kingdom and among plants really do occur more or less in this range, a little bit lower for some insects and a little bit higher for some plants. But by and large, most biology really takes place in this range here. So having sensors that are able to detect these wavelengths is actually extremely useful for studying the planet. And so again, we have this term visible spectrum from 400 nanometers to 700 nanometers. And what I want to do is I just want to take a minute and I want to sort of deconstruct this a little bit. And this is something that I would recommend that you internalize here. If nothing else, then just a couple of these key regions. So the first region is going to be from approximately 400. So the first region is going to be 400 to approximately 500. Right, this is going to be your blues. Actually, let's go ahead and throw some units in there. 400 to 500 nanometers. Right, this is going to be your blues. And then from around 500 to roughly 580 to 600, right? These are going to be your greens. Right, so again, I'm taking the wavelength concept that we talked about previously, right? That distance from crest to crest. And now I'm tying it in with the colors that we're familiar with in our everyday life. So if the wavelength is between 400 to 500 nanometers, right, our human perception would see those wavelengths as blue. 500 to 580, our eyes would perceive those wavelengths as green. We do have a little bit of yellow here, from about 580 to about 600. These would be yellow. From 600 to about 650 nanometers. These would be your oranges. And then finally, from 650 to about 700, these would be your reds. So again, I just took this visible spectrum here and I've broken it up by color. And again, these are approximate wavelengths, but this is a really good sort of frame of reference when we start talking about different things to just keep in the back of your mind and remember, oh yeah, we're going to talk about bands in a later video. This band is measuring roughly in the region 650 to 700. It must be measuring red electromagnetic radiation. Hopefully this made sense. If it didn't, I encourage you to go back, pause the video, rewatch the parts you're confused about, and as always, please reach out. Thank you.